Alrighty, so here we are, another questions. Take a moment, make sure it's working. Everything's working here. Make sure the audio is working. Hello, it's working here. Nice, it's going. Okay, this question is statistics from a large sample. Let's get that going. Okay. Statistics from a large sample, all right? You are given a large sample of integers in the range 0 to 255. Since the sample is so large, it is represented by an array count, where count of k is the number of times that k appears in the sample. Calculate the following statistics: minimum, the minimum element in the sample; maximum, the maximum element in the sample; mean, the average of the sample, calculated as the total sum of all elements divided by the total number of elements; median, if the sample has an odd number of elements, then the median is the middle element once the sample is sorted. If the sample has an even number of elements, then the median is the average of the two middle elements once the sample is sorted. Mode, the number that appears the most in the sample, it is guaranteed to be unique. Okay, these aren't too hard to pick up. So minimum, maximum, mode, mean, all of these are, well, how many of them are there? Counted by, oh, okay, it could be 1 billion times 256. All right, but the sum is only 1 billion at most. Okay. The mode of the sample that count represents is unique. Oh wow, not a lot of submissions. This is not that hard. Why did people struggle so much with this? This is just, they give you a frequency map and you gotta analyze some statistics. Yeah, the sum is only 1 billion, so that means that the average can be calculated directly. Mean, so this is not too hard. And then, or actually, hold on. Oh no, excuse me. Yes. I got that right. Yes. The sum is going to be at most 1 billion, which means the mean is not that hard to calculate. And the median is a little tricky, but it's not that hard, quite frankly. Yeah, we should be able to calculate the median. Yeah, that's pretty much it. I think for the median, the best way to do it is to actually double, so that you're always dealing with an even case. Just double the two, just double the numbers you see. And again, being less than 1 billion, this will still fit in an int. Being 1 billion, yeah, it's just for the median, you just double the numbers you're dealing with, and then always treat it as though you have an even number. Because if the whatever the median is, if you double the numbers on the left side and the right side, it's still the same median, right? And then same thing for if it's odd, then you just end up with the median twice. So it's it's a neat kind of trick to make this a lot easier. Yes, it's not bad at all. Okay, so the min is going to be for I less than, so we'll say bound 256. The length is 256, so less than bound is what we want. Int min, and I think it's always at least 1, right? Yeah, it's always gonna be at least one element in there. Min equals, so if count of I, and set min equal to I and break. Same thing here from the top. I is bound minus 1. I is greater than or equal to 0. Decrement I, count of I, then we'll say min val is a little bit better than min. I don't like to use min and max because it's too similar to the functions. Max val, and it bothers me regarding just like naming convention. Yeah, so the min val, max val, it's not too bad. The Mean is just take the sum. Yeah, total. Actually, oh no, I was wrong. Yeah, I was wrong. Total should be, still it's not that big of a deal. I times counted by. And then I guess these are all it's an array of vector of doubles, yeah. Result. So min val, how does it work? It's gonna be min, max, and then mean. Okay. Could just reserve 5 elements, I think. 1, 2, 3, 4, 5. Total divided by frequency, or no, total frequency. Total sum. Total frequency. Okay, the median is a little more interesting. So we're gonna say treat the total frequency bit shift by 1. And we're gonna say should be like at most 2 billion. We're gonna say int we'll just say current frequency is total frequency. Kind of I want to do like chunks, right? I want to do there's like a target frequency, let's say. Target frequency is, let's do it this way. Let's do this total frequency target, that's the target frequency. And we're gonna say the target, or a target, and then current. So we're gonna increment current by count times 2, right? But I'm only gonna do this under certain conditions. So if current is greater than or equal to target, then break and set left equal to, let's do left is I. There's a few things that are going to happen here. Left is I, right is I, no. Yeah, let's do it this way. So something like this. So we'll say left equals I, current target plus 1, then right equals I. Okay. And left is equal to -1. Choose optionals, let's do it that way. All right, okay. Yeah. Okay, I would say if it's greater than or equal, as long as it's less than target plus 1, we can keep going. Once it's greater than or equal to target plus 1, then we've gone too far. It's a little confusing, I realize. Okay. This could be target and target -1. I'm just trying to think. Current less than target plus 1. Increment here. Yeah. Okay. So if we covered that, so if we have 4 elements, let's do 4 elements. 4 elements, 0, 1, 2, 3. I want 1 and 2. Let's say I had 2 elements. Current becomes 2. That covers 0, 1. 4 divided by 2 is 2. It's actually target -1 and target. Yeah, because the part that's confusing about it is comparing could be less than or equal to target 2. No, well, yeah, you could, yeah, well, okay. I guess we'll just say and not right, and it's really if these are not set. That's really if not right or not left. Once those are set, then we're done. Yeah. Okay. Yeah, the issue is that I'm used to using current as an index, not as a what do you call that? It's an index, not a number of elements, right? So anyway, so if current is greater than or equal to target -1, then we set left, and not left, then we set left, and then if current is greater than or equal to target, and we haven't set the right value, then we set target right as well. Yeah, basically we jump a bunch of elements and check to see if these 2 elements are contained in there or not. Then I think that's really it. And it's also I is less than bound. Yeah, that's pretty much it. Then we can say result.pushback. This is going to be left plus right divided by 2.0. So these will be integers. Yeah, something like this should be fine. And then finally, the mode is just the largest. Yeah, maybe it's better if I just do it all in one loop. Min val, max val, mode. And then finally, if not mode or count of I is greater than mode, and set the mode equal to count of I. Okay, this is maybe a little bit easier to think about. Yeah. So min val, max val, mode, something like this. Okay, this took me quite a while to program, quite frankly. How am I doing? Total sum. Okay. 60 minutes. I mean, not ideal. Double. Oh, okay. Sure. Hopefully that works. Total. Okay. Forgot that I refactored that name. Wrong. No. Saying so. Min, max, median, mean, the median, and the mode. These are the ones that are a little more interesting. So I got 4. Oh, no kidding. Really? I think it's not the count. I think it's supposed to be the element itself. Yeah, that was my mistake. Which is still wrong, actually. Mode size, mode. Yeah, a little more complicated than that. A little more complicated. Okay, got the mode right, but now this is the median. Okay, so it's supposed to be 2.5. I got 2. So we have 1, 2, I think, right? It's between 1 and 2, 0 and 250. So it's 0. Oh, yeah, 255 inclusive. Yeah, so I got some evidence. Okay. So 0, 1, 3 2s, and 4 3s. So that's 8 elements. It becomes 16 elements the way that I'm calculating it, but 8 elements. We get oh, I know I did wrong. Oh no, it's fine. I was gonna say I did that right. So it'll be 1, 2, 2, 2, and then 4 3s. Excuse me. So it should be 2 and 3, right? 1, 2, 3, 4, 5. Should be 2.5. Oh, I got 2. Okay. Yeah, so if I double the total frequency, and then I make my target halfway through, right? So if I make it 16, and then half of 16 is 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Index 8 is actually position 9. Interesting. Let me write it down. Try to think about this correctly. Yeah, that's pretty tricky actually. I thought it would help to use double values, but it doesn't seem to help that much. So 1, 1, 2, 3, 1, 2, 3, 4. We double everything. Okay, now I'm looking for 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's 8 on the left side, 8 on the right side. Okay, that's fine. This is 8th, 8th, and 9th, starting from 1. I think maybe this is what I'm supposed to do then. Yeah. So I add 2, then I add 1, 2, 3, 4, 5, 6, and I add 6, and then now I'm at 8, and I contain 8. And then the next one I add another 8, I'm at 16. Yeah, I think that works. Okay. I don't know, that was kind of confusing. It was challenging off by 1 error, that one. Okay, let's try. I don't really want to generate more test cases. It seems kind of, I guess I could just add random things in here, right? I don't know. Could try something like this, right? How about just a whole bunch of 1s? 1, 1, 1, 10, 2, 3, and then we can make this like a 1, 1, 1 type of a deal. Something like this, I don't know. Oh, mode must be unique, okay. Oh, okay. I don't know. Okay, the mode must be unique. Got it. I'm gonna go for it. This could be wrong. Could be something I missed. It's kind of challenging to go through all the test cases. Oh no, we got it. Nice. 20 minutes. It's not too bad. 0 milliseconds. Beautiful. Yeah, it's pretty fast, actually. 255 operations, basically. This part of the code, though, is really the kind of the smartest part. This is very clever. Yeah, but very cool. We'll submit it 5 times, and we got 20 minutes or so. That wasn't ideal in terms of time, but it's reasonable. It's not crazy. We'll do it a few more times. I'm trying to think what I want to do. I think I want to submit it a few more times. 1, 2, 3, 4. I think one more. 1, 2, 3, 4, 5. And I'll say if you like the video, give it a like, and if subscribe for more. I'm going to go ahead and stop this one here and restart on another question. So that wasn't too bad. That was okay. I could have done it faster. I could have done that a little bit better, but that was reasonable.